The final example that we'll take a look at is we're asked to sketch a parabola that has a width of 10 units and a height of 7 units. Okay, so we want to start our parabola at the vertical axis. So if we're starting our parabola at the vertical axis, we know that it's going to start here at 0, 0. Okay, and we know that it has a width of 10 units, so 10 units is all the way out here. Okay, and it has a height of 7 units. So somewhere it has a maximum height of 7 units. Okay, so what we need to figure out is, well, just how high. And when we talked about the axis of symmetry, remember the axis of symmetry divides a parabola in half. So if that's our parabola, then the axis of symmetry actually divides the parabola in half. So if we know that the parabola is 10 units wide, then half the distance of 10 is at 5. So that means that its maximum height actually happens to be at 5, 7. Okay? And we know that this point here is at 0, 0. And this point here is at 10, 0. Okay? So now we have a parabola. And we can actually draw this. Again, my drawings are terrible, but there's our parabola. Okay? So what we need to do is we have to actually figure out, well, what's the equation for this parabola? And there's a couple of pieces of information here that we already know. So we know now that we have the vertex, so this is the vertex here, we can figure out at least our h and our k values. Okay? So our h value is going to be 5, so positive 5, and our k value is going to be positive 7. Okay? The h value is positive 5 because it's to the right of the vertex. So if this is in fact our the beginnings of our parabola, we can figure out the remainder. Okay? We know that a is going to end up being a negative number, and we can double check that. But we know that all parabolas are written in the form y equals a times x minus h squared plus k. And we know what our h and k values are. Now we just need an x and a y coordinate. So we could choose either 0.00 or 0.10. So for simplicity's sake, I'm going to make use of this point here, 0.00. So I'm going to substitute in my xy coordinates of 0, 0 into this as well. So my y coordinate is 0. I don't know what my a coordinate is. That's what I'm trying to figure out. I know that my x coordinate is also 0. My h coordinate is minus positive 5 all squared, and my k coordinate is 7. So now I'm going to use BEDMAS to try and simplify what's in the middle here. Okay, so 0 is equal to a. 1 minus positive 5 is negative 5 squared plus 7. So 0 is equal to 25a, because negative 5 squared is 25, and 25 times a is it's 25a plus 7. Okay, so now what I need to do is I need to get this a value all by itself. So what I'm going to do is I'm going to start off by subtracting positive 7 from both, or I need to subtract 7 from both sides, because the opposite of positive 7 is negative 7. So 0 minus 7 is negative 7. And positive 7 minus 7 is 0. So I'm just left with 25a. So then I need to get rid of this 25, which is being multiplied by a. So I'm going to divide both sides here by 25. So both sides are divided by 25. And so that means that my a value is actually negative 7 divided by 25, which is negative 0 point, that's a terrible way to put that, which is actually negative 0.28. Okay, so now that I've identified what my a value is, I have to actually complete this by saying what the equation of the parabola is. So therefore, now that I have my a, h, and k value, my equation of the parabola is going to be y is equal to negative 0.28 times x minus 5 squared plus 7. And again, it's minus 5 because the sign needs to be the opposite of the actual value of h. Okay? So again, using the algebra, we can figure out how to come up with an equation for any given position that allows us to apply the parabolas really well. And so this type of an example could be used quite extensively if you were doing some type of construction.